Hey guys, I'm Remiah Dela Cruz, a senior high school student from Rizal National Science High School. And today, we're going to learn about the trigonometric ratios. So are you guys ready? Come on, let's start. So, the first thing you should know is that trigonometric ratios are applied only on right triangles. So if you have a non-right triangle, the trigonometric ratios cannot be used. Now, before I start talking about that, let's first identify the parts of a right triangle. The longest side of a right triangle is called the hypotenuse. The hypotenuse will always be the side which is opposite from the 90-degree angle. And these two sides are called the legs of the right triangle. In getting the ratios later on, these two sides will either be opposite or adjacent side, depending on our theta. The theta is the designated non-right angle. So if the theta is placed here, then this side will be the opposite. And this one next to the theta will be the adjacent side. There are 6 trigonometric ratios. We have sine, cosine, tangent, cosecant, secant, and cotangent. For you to easily remember, there is an acronym you should know. SOHCAHTOA and CHOSHCAHTOA. What does this mean? So means sine of theta is equal to opposite over hypotenuse. Ka means cosine of theta is equal to adjacent over hypotenuse. TOA, tangent of theta is equal to opposite over adjacent. Now, a thing to remember, cosecant is just the reciprocal of sine, secant is just the reciprocal of cosine, and cotangent is just a reciprocal of tangent. So cosecant of theta is equal to hypotenuse over opposite. Secant of theta is equal to hypotenuse over adjacent. Cotangent of theta is equal to adjacent over opposite. Let's look at examples of right triangles and determine the 6 trigonometric ratios. So this is our given right triangle, and this is our theta. So let's start with sine. Remember again the SOHCAHTOA and CHOSHCAHTOA. Sine is equal to opposite over hypotenuse. So the opposite side of this theta is this side, which is 3, over the hypotenuse, which is 5. So sine of theta is equal to 3 over 5. Next, cosine of theta. Cosine is adjacent side over hypotenuse. This is the adjacent side, which is 4, over the hypotenuse, which is 5. So cosine of theta is equal to 4 over 5. Next is tangent of theta. Tangent of theta is equal to opposite over adjacent. So opposite side over adjacent side. Tangent of theta is equal to 3 over 4. So in getting the cosecant of theta, just get the reciprocal of sine of theta. So 3 over 5, the reciprocal is 5 over 3. For secant of theta, get the reciprocal of cosine, 5 over 4. And for cotangent of theta, get the reciprocal of tangent of theta, 4 over 3. Now, let's proceed to the next example. In this example, our theta is placed here. So again, we'll start with sine. Sine of theta is equal to opposite over hypotenuse. Opposite, 12 over hypotenuse, 13. Sine of theta is equal to 12 over 13. Cosine of theta is equal to adjacent over hypotenuse. So 5 over 13. Cosine of theta is equal to 5 over 13. Next is tangent. Tangent of theta is equal to opposite over adjacent. So 12 over 5. So remember once again that cosecant of theta is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So once you get these three, just get the reciprocal for these three. The reciprocal of 12 over 13 is 13 over 12. The reciprocal of 5 over 13 is 13 over 5. And the reciprocal of 12 over 5 is 5 over 12. Let's try one last example. Again, we'll start with sine. Sine of theta is equal to opposite over hypotenuse. 12 over 15. Cosine of theta, adjacent over hypotenuse. 9 over 15. Tangent of theta, opposite over adjacent. 12 over 9. And again, just get the reciprocal of these three. 15 over 12, 15 over 9, and 9 over 12. So that's all for trigonometric ratios. I hope that you guys learned a lot and that you were able to understand the topic. Thanks for watching and see you around, guys.